In this video, we will see generalized Hooke's law. So we all know that Hooke's law is stress is proportional to strain. So here we have sigma x in one direction, sigma y and sigma z are in perpendicular direction. All three are in different directions. We know that epsilon x is equal to sigma x divided by Young's modulus. So we know that sigma by E, but this other term here, epsilon x is equal to delta L by L is equal to sigma by E. We know when it is a uniaxial direction, these two stresses are not present. So both this term will be zero. So stress is directly proportional to strain in that direction. But what if we have stresses in three different directions on the same material? Then Poisson ratio come into picture, because stress in one direction affects the strain in other direction also, because of the Poisson ratio. If we stretch some material in one direction, the other two direction cross section and length and breadth will decrease, other two direction length will decrease, and the direction in which we are giving the stress, in that direction length will increase. So these all three stresses will affect the strain in all three different directions. Sigma y will affect in x and z direction length, sigma z will affect length of y and x direction also, because of the Poisson ratio. Now for that we have generalized Hooke's law. It says that epsilon x, if you have to find, it will be equal to change in length upon the length in x direction, which will be equal to this formula. If I open the bracket, it will be sigma x by E. So that will be the change in length in x direction, but due to sigma y and sigma z, and because the ratio, Poisson ratio, we have reduction in the diameter. If we these all are by default taken as positive. If they are taken, if they are compressive, then we have to put it as negative. So sigma x by E will increase the length epsilon x, but epsilon x will reduce if we give in stress in y and z direction, because of the Poisson ratio. So sigma y by E into Poisson's ratio will give the reduction in epsilon x, and similarly in z direction. So this entire term will be generalized Hooke's law if all three sigma x, sigma y and sigma z are present. So that will be the total strain in x direction. Similarly for y direction, change in breadth upon breadth means change in length in y direction. We are giving sigma y in y direction, so this is trying to increase the strain, but these two, sigma x and sigma y, are trying to decrease this epsilon y, but it is times the Poisson ratio. So we have to multiply with minus mu, because it is reducing epsilon y. If we stretch it in x direction, the length in y direction will decrease. This y direction length will decrease because we are stretching in this direction. Epsilon x will try to increase the length in x direction. At the same time, it will decrease in y and z direction length. And similarly for z also, z is trying to increase length in z direction, but it's trying to decrease length in other two direction. And the same goes for epsilon z, sigma z by E minus mu sigma x by E minus mu sigma y by E. So this is generalized Hooke's law. We simply have to put the values of sigma x, sigma y and sigma z, and we will be given with a Poisson ratio something like zero point 0.3, 0.33 or zero point 0.4 in the question. So this is how we find strain in different direction and change in length upon length in all the three direction we can find. And this formula are simply, if we take E common and then mu common from both these terms. So this is how we can write generalized Hooke's law. Now we'll look at volumetric strain. So volumetric strain will be summation of the strain in three different directions: sigma, epsilon x, epsilon y, epsilon z. Simple summation, which will be equal to change in volume upon the volume of this. So change in total volume of the this element upon the volume of this original volume of this element. And if we place all this generalized Hooke's law in these three terms, epsilon x, epsilon y, epsilon z, then will get this equation in terms of stress: 1 minus 2 mu upon E. E is a Young modulus, mu is a Poisson ratio, times sigma x plus sigma y plus sigma z. So that will be the change in volume upon volume, which is volumetric strain of this particular element if it is loaded with three different loads. Here the load px, some in Newton, will be there, but I have shown it in terms of stress. Py and pz also can be shown, but we have to divide it by area to get the stress value in three direction. Now we will look at the relationships between sigma 1, sigma 2, and sigma 3. These are principal stresses in three different directions. This is a stress element, and these are the principal stresses for this stress element. So if you find principal stresses and principal strains, which we have discussed in previous videos, then we can find these relations by simply putting these values in this generalized Hooke's law. So epsilon 1, epsilon 2, epsilon 3 will be simply sigma 1 by E minus mu sigma 2 by E minus mu sigma 3 by E. So simply we have to keep this x with 1, y with 2, and z with 3. Similarly for strains. So if we put in this formulas, then we get this equation. So now if this is for 3D element, because this three direction stress is present and three direction strain are present. If sigma, epsilon 3 will still be present in two dimensional element, because let's see here, you will find the reason. So here for 2D stress, 2D stress element, sigma 1 sigma 2 will be present, but sigma 3 will not be present. Now if sigma 3 is not present, if we keep sigma 3 is equal to 0 in these three equations, we get epsilon 1 as 1 upon sigma 1 upon E minus mu sigma 2 upon E, but sigma 3 is 0. Epsilon 2 principal strain in second direction, means in y direction, or the principal second minor principal stress direction, which is denoted by 2 sigma 2 by E minus mu sigma 1 by E. Sigma 3 is not present, but here stress is not present, but due to sigma 1 and sigma 2, strain in third direction will be present. Like I have said here, sigma 3 will be present, all three strain will be present, and two stresses are present. So two direction stress, bidirectional stress will give strain in other direction also, because it is related by Poisson ratio. So here sigma epsilon 3 will be equal to 0. 0 is of sigma 3. Sigma 3 is 0 minus mu times sigma 1 by E minus mu times sigma 2 by E. So strain will be present even though stress is not present in that direction. Similarly, we can find biaxial stress for this if we keep sigma z equal to 0. So these are the equation for principal stress and principal strain. We can find it from these equations. We can subject sigma 1, sigma 2, sigma 3 from these equations, and we can find in terms of epsilon 1, epsilon 2, and epsilon 3. But that will be too much to remember. Simply we have to keep values here, and we have to evaluate equation by elimination method, and we can find vice versa all the terms from these equations also. So no need to remember those equations of sigma 1 and sigma 2, sigma 3 in terms of these three values. So this is a generalized Hooke's law. Sometimes questions asked from this topic, and this is very basics, and it can be asked in any interview. And it is very conceptual that strain in one direction affects the strain, stress in one direction affect the strain in other two directions also. So thank you for watching this video, and see you in the next video.